Everyone, welcome to this class. In this class, I'm going to deal with number bases. The common number base we use for our everyday operation is base 10. And there's one thing you notice about it. You have something like 1, 2, 3, 4, 5, 6, 7, 8, 9. And then you now have 10. If you check this 10 very well, you'll notice that it just simply means 1 and 0. The next thing is 1 and 1. 1 and 2. After that, next thing is 20, which is like 2 and 0. So what actually happened is that the base we are dealing with in real sense does not appear. Let's say, for example, we are dealing with base 5. Let's do base 5. You'll notice that when we want to count it, you have something like 1, 2, 3, 4. Sorry, we don't have 5. When you now reach 4, the next thing you are seeing is what? 10. When you reach 14, next thing is 2 and 0. So that particular base you are dealing with is not always in the picture. So first, we are going to do in this class, we are going to learn how to convert from one base to another base. So let's do that. Example 16a. We are being told to convert 4et in base 12 to base 10. What does this et mean? When you are dealing with number bases, let me write it out first. So this is summary of the number bases. Now I did from base 2 to base 16. You can see that the base you are dealing with, it doesn't appear in its number bases. 2 stops at 1. So the next thing will be 1, 0. The next one will be 1, 1. And it continues going like that. We are going to do it in this class. 3 stops at 2, 1, 2. The next thing will be 1, 0, 1, 1, and so 4 stops at 3, 5 stops at 4. This is how it goes. Then this is base 10, the one we are used to. It stops at 9. We already know that next thing is 1, 0, 1, 1, and the rest. Now when we go to base 11, when we number it to 9, this is what we are which is like the base 10 we are used to. The next number we don't like, it's not something we've operated with, so we represent it with A. Base 12 we represent with A, B, base 13, and so on. But in this case, this example, if you look at, they are representing it with another alphabet, E, which is like 11. When you spell 11, it starts with E. And T, which is like 10. When you spell 10, it starts with what? What do you call it? It starts with T. And mind you, this A now is like 10. You understand? But this 10 is not the same as when you want to move to the next order. Like, I don't know how to explain it. Like here, when we have base 10, when we finish, we now say 11, that will move to the next order. When we reach to 19, we move to the third order, which is 20, and the rest. So that's why we represent it with an alphabet, because it's not the same as when we finally exhaust this base 11 and we now do this 1 and 0, because we are going to get there. So the same applies to this 12. This is like 10, 11, 12, 13, 14, okay, 50. Yeah, that's it. So when you want to calculate for it, you replace it with what you know about in base 10. But from this base down, it's not something we are used to. So that's why we introduce alphabet. So in this case, it's not the alphabet I introduced at them. They introduce in the textbook. So this 11 this is for 11. That's in base 12. That's the A in my own case. And this is for 10. Sorry, I think I made a mistake here. This is 10 and this is 11. Because you will not have 12 in base 12. So this is for A, this T is for A, and this E is for the B I have here. But don't worry, when we start, as we solve more example, you understand. So what we are going to do, if you are being told to convert a number to base 10, so let me write it out here. Let's now solve for the solution. We have A, 4et. To convert to base 10, just multiply each and of, because it's already in base 12. I forgot to. So multiply each of them by 12 and put it to the order. So this will be 4 times 12 plus E times 12 plus T times 12, right? Now you start from the last one. This is the unit. Remember, unit, tens, hundreds, 1000, and the rest. So this will be 12 raised power 0. This will be 12 raised power 1, and this will be 12 raised power 2. So let me remove this alphabet and express it in digits. To be 4 times 12 raised to power 2 plus, this is 11. 11 times 12 raised to power 1 plus 10 times 10, 12 raised to power 0. So by the time you express it, 4 times 10 raised to power 12 raised to power 2 is 144, plus 11 times 12 raised to power 1 is still 12, plus 10 times 12 raised to power 0 is what? 1. Remember our law of indices. So by the time you do this calculation, you are getting 718. This time around it will be in what? Base 10. So when you are converting a number, any base to base 10, each of the digits of that number will be multiplied by the base. Then you now raise it to the power, starting from the unit sign 0, 1, 2. If you have any other one, you continue 3, 4 till wherever it stops. You solve it. Whatever you get is the base 10. So let's go to B. B says divide. Are we together? We have in B we have 077 in base 10, and we are told to convert it to base 8. So converting from base 10 to base 8 to other bases is a different thing. I'll show you how you go about it. Just do it as if you are doing the long division method, and then this is a number. The number will be inside it, while the base you want to convert is what you are using to divide. So let's start dividing. Are we together? 8 divide into this, you have 259, remainder what? 5. You continue with the same 8. 8 divide into this, you have 32, remember what? Remainder what? 3. Continue with the same number. 8 divide, you have, I think this is 4, remainder what? 0. Still 8 again. 8 divide, you have 0, remainder 4. So you use the base you have to convert to. You keep dividing and bringing out the remainder till you have 0 here. That's when you stop. Then you will now take it from down up. So it will be 4, 0, 3, and 5. Or in base what? 8, no longer in base 10 again. To also refresh our mind on this, let's convert this that is already in base 10 to base 12. Let me call this C. We are the one just doing this. We have this in base 10 to base 12. So to know if we are getting this back, are we together? So let's start. I think this is not even the best thing because of the alphabets that are there. Are we together? So if we divide this by 12, what are we getting? We get 59, remainder 10. If we divide again, we get, I think I'm missing something. We get 4, remainder 11. 12 divided again, you have 0, remainder 4. Now we've gotten 0, meaning that we have come to the end of the road. So we now, all the remainder, we'll take it from down up. We have 4. The next one is 11 as a digit, because we are doing in base 12. So 11 is a digit in base 12, not 2 digit. The next is 10. 10 as a digit, all in base 12. So if we are to change this to the alphabet, we get what we initially solved for. 11 was replaced by E, while 10 was replaced by T, all in base 12. So are we together? So that's the way to solve. If you are to solve, convert any number to base 10, multiply the digits of that number by the base, raise it to the appropriate power. Whatever you get is base 10. But if you are to convert from a number to base 10, simply keep dividing and bringing out the remainder till the final division is 0. Then you pick the digit from down to up. Whatever you get is the base of the new base that you are converting from base 10 to. Let's go to the next question. So let's go to example 17. We are going to convert 1, 2, 6, 4, 8. That's in base 8 to base 10. Remember what I said? Each of the digits multiplied by the base. So 1 times 8 plus 2 times 8 plus 6 times 8 plus 4 times 8. So from the unit side, 0, 1, 2, 3. So what you now have is 1 times 64. Am I getting it? No, not 64. 512. 8 raised power 8 times 8 is 64. 64 times 8 is 712. Plus 2 times 64 plus 6 times 8 raised, this is 8 raised power 2, so that's 64. This is 8 raised power 1, which is still 8, plus 4 times 8 raised power 0 is what? 1. So by the time you multiply this, 1 times 1, 512 is still 512, plus 2 times 64 is 128, plus 6 times 8 is 48, plus 4 times 1 is still 4. So your answer is 692, 9 in base 10. See how easy it is to convert any number base to base 10. There's another formula you can use to solve this. This formula is even more easier if you're using your calculator. Let's go for the second method you can solve this for. So the second method you can use to convert any number to base 10. So this is 1264 in base 8, and you have to convert to what? Base 10. What are you going to do? Start from here. Are we together? So you do 1 times 8 is what? 8. Still 8. You now do whatever you get here plus the next number plus 2 is now 10, right? That 10 will multiply by 8 again. 10 times 8 is what? 80. Then this 80 plus the next number, which is 6, that's 86, right? This 86 again now times 8. Why we are using 8 is because we are dealing with base 8. If it's another base, either base you are using is the base you use to multiply. So let's continue. This 86 times 8 is 688. This 688 plus 4 is what? 692. Mind you, for the last digit you don't need to multiply. After you add it to the last digit, you don't need to multiply again. So this is in base 10, and if you look, we are getting the same answer. As you are doing this method, is much easier if you are with your calculator. You just carry your calculator and say 1 times 8, whatever you get, which is 10, plus 2 times 8 plus 6 times 8 plus 4. Whenever you reach the last digit, don't multiply again, stop there. So this is the two methods you can use to convert any base to base 10. Are we together? So the next thing we are going to do is also, maybe I would like to convert this in base 10 to base 8 and see if we are getting the same answer. Already we have 692. So let's convert it to base 8. 692. Are we together? So the next thing we are going to do is, let me call it example. We have 692 in base 10 to base 8. So let's start. 692. 8 divided by 692. We are getting 86. Remainder what? 4. 8 divided by 86. We get 10. Remainder what? 6. 8 divided by 10. We have 1. Remainder what? 2. And 8 divided by 1, we have 0. Remainder 1. So by the time you take it up, you have 1, 2, 6, 4, all in base 8. If you check this and check this, we are getting the same answer. So these number bases are very, very simple. Just understand the techniques behind it and you'll get it. So let's solve exercise 3H. Number 1C. We have 128 in base 8 to convert to base 10. Simply draw your diagram. Are we together? So this is base 10 convert to base 8 according to the question. So when you draw your diagram, 128 in base 10, and this is the 8. So let's start. our conversion. So 8 divide 128, we have 16, remainder what? 0. 8 divided by 16, 16 divided by 8, I mean to say, you have 2, remainder 0. 2 divided by 8, we have 0, remainder 2. So we take it up, and our answer is 200 in base 8. Now we have 115 in base 10 to convert to base 5. So let's the same method. 115, 5 divided by 115, we have 23, remainder 0. 23 divided by 5, we have 4, remainder 3. 4 divided by 5, we have 0, remainder 4. Now we have already gotten 0. Once you get 0, that's where you stop. So you take it up, we have 430 in base what? 5. Here, number 3H, we are supposed to convert 39 in base 10 to base 2. So we have 39. So let's start. 2 divide, we have, okay, this will be 1. Take 1 here, 2 divide, 9, remainder 1. 2 divide, we have again 9 again, remainder 1. 2 divide, we have 4, remainder 1. 2 divide, we have 2, remainder 0. 2 divide, we have 1, remainder 0. 2 divide, have 0, remainder 1. So we take it up. 1 0 0 1 0 0 1 1 1 1 1 1 in base 2. You see how easy and simple it is to convert a number from base 10 to other bases. The same method, but use the base you want to convert to divide.